So, for decades, the tech world was really focused on that big fight. You know, Intel versus AMD, the CPU war. All about clock speeds, doing things one step at a time, faster and faster. But while everyone was watching that, nVidia, well, they kind of just won the whole thing by changing the rules.
That's exactly it. They basically sidestepped the whole CPU battle. Instead of making one super fast brain, they bet on, well, on thousands of smaller units working together, accelerated computing. And the money, I mean, wow, you look at the numbers. They blew past a US $1 trillion valuation back in 2023. And now, well into 2025, pushing past $4 trillion. They're a core Magnificent Seven company now, leaving the old rivals way behind.
Right. So today, let's dive into that. How do they see this coming, this massive shift from, like, needing one fast processor to needing millions working at once, years ahead of time?
Well, you actually have to rewind quite a bit, back to the first graphics wars. Mid-90s, that's where they learned the really crucial lesson. It's the ecosystem, not just the hardware, that wins in the long run.
Okay. Like, after their first chip, the NV1 didn't do so well.
Right. Exactly. They made this key choice to back open standards, DirectX, OpenGL. Unlike rivals, remember 3DFX, they had their own closed system, Glide. NVIDIA went the other way. And that bet on openness, on making it easy for developers, that really set the stage for everything. They even ended up buying 3DFX later.
Okay, so that lessened ecosystem over proprietary tech, did that directly lead them to CUDA?
Absolutely. CUDA, launched in 2006, was kind of prophetic, wasn't it? They saw that the GPU, this thing designed for pushing pixels, was basically a supercomputer just waiting. CUDA was the key, the software bridge. It let scientists and engineers program these massively parallel GPUs using familiar languages like C++A.
Making it accessible, not just some weird specialized hardware.
Exactly. And this wasn't cheap. It was a huge multi-billion-dollar bet sustained over years, long before AI was really a big thing. That's what turned them from just a chip company into, a platform company, hardware and software.
And that bet really cashed in around 2012, right? The AI tipping point, the AlexNet moment.
The ImageNet challenge. This deep neural network just shattered accuracy records for image recognition, like 15.3% error rate. Way better than anything before it.
But wait, I heard that breakthrough. It wasn't run on some giant supercomputer, was it?
No, that's the kicker. It ran on 2 NVIDIA gaming GPUs, GeForce GTX 580s, off the shelf. Suddenly, a task that would take months on a CPU, done in days. That moment right there proved the whole accelerated computing idea for AI.
So, okay, it worked. But why? What is it about a GPU that makes it so good for AI, fundamentally?
It boils down to the math. The core job in AI training is matrix multiplication, tons and tons of it. And that's something you can break down into many small parallel calculations, exactly what GPUs are designed for, with their thousands of little cores. A CPU is great for complex single tasks, one after another. A GPU is great for doing millions of simple tasks all at the same time.
Got it. So the hardware was naturally suited, and then they built the software advantage on top of CUDA, the moat everyone talks about.
Yep, that's the moat. Things like CUDA, basically libraries of pre-built, super-optimized code for common AI tasks, and TensorRT, which helps make the AI models run faster once they're trained, for deployment. It locks developers into their ecosystem because it just makes everything easier and faster.
And they didn't stop at software, Farah. They went into whole systems.
Right. They moved from selling just cards to selling complete AI factories, like their DGX systems. And crucially, they bought Mellanox in 2019. That was huge, $6.9 billion.
Mellanox.
Yeah.
They do networking tech, right? InfiniBand.
Exactly. Because when you link thousands of GPUs together for these massive AI models, moving the data around becomes the bottleneck. Buying Mellanox gave them control over that critical high-speed interconnect. The whole stack, top to bottom.
So looking ahead, they seem to be using the same playbook everywhere. D-Drive for cars, Isaac for robots, Omniverse tying it together.
Yeah, replicating that full stack model. But, that kind of dominance, it puts a massive target on your back.
Right. What's the main vulnerability then?
It all comes back to CUDA, that software ecosystem, that moat. It's proprietary, it's locked. So you've got competitors like AMD pushing hard with their open source alternative, ROCm. But maybe the bigger threat, NVIDIA's own biggest customers, the hyperscalers.
Like Google, Amazon, Microsoft.
Exactly. They need this AI compute power at massive scale, but they hate being locked into one supplier, especially an expensive one. So they're all designing their own custom AI chips. Google's TPU, AWS's Trainium, Microsoft's Maya, trying to break that dependency.
So NVIDIA basically won by building this incredible software fortress on top of their hardware. a whole new battlefield. But making it a walled garden gives everyone else, competitors, customers, a huge reason to team up and find ways around that wall. The fight over open versus closed AI platforms feels like it's really just getting started.